Dear students, in the previous lecture, we have looked at the elementary aspects about errors. We have also seen how errors can occur during a titration. In this lecture, we will look at the next topic, which is accuracy and precision. When you are handling a set of data that is generated from an experiment, you can take any experiment like running a titration or doing a potentiometric titration or recording some physical constants like melting point or boiling point of any substance. When you have such set of data, you can check whether these data are accurate and precise. First, we will see what is precision. Precision describes the reproducibility of a measurement. In other words, it also shows the closeness of the results that have been obtained in exactly the same way. When you have multiple set of data generated out of an experiment, you can say whether they are precise or not. But how to check whether they are precise or not? We need to see how close these set of values are. When these values are closer to each other, need not necessary that they should be close to the exact value or the true value, but if they are closer to one another, we can call them as precise data. You can see from the picture given here that you have concentric circles which represents different set of values, and the center circle represents the true value, and all the dots that you find there are the set of the data that you got from the experiment. The data, that is the picture that you see on the left hand side bottom, you can see all the data are concentrated at the center circle, which means they are closer to the true value. You can call them as accurate values. At the same time, they are closer to each other. So you can also say that these values are precise in nature. Similarly, in the second picture given at the bottom, you can see that these values are closer to each other, which means they are precise, and they are not accurate because they are far away from the center circle, which represents the true value. Next, we'll see what is accuracy with the help of a few more diagrams. Accuracy indicates the closeness of the measurement to the true value or accepted value. When we say that you have a set of data, sometimes these data may be closer to each other, which means they are precise, but they are not correct, which means they are not accurate. When we say they are not accurate, they are not closer to the true value or the accepted value or the absolute value. So the pictures that are shown here shows us the different set of data and how they are distributed. The first picture on the left top shows low accuracy and low precise data, and the next one shows low accuracy and high precise data, which means the low accuracy represents that these data are away from the true value, and high precision tells us that these values are actually closer to each other. Similarly, the next picture at the bottom left shows high accuracy and low precise data, and the next one shows high accuracy and high precise data. If we see these values represented by dots, we may have some doubts. So we will go into the actual data. So these are this table has the melting point values of 3 different students. It is the melting point is recorded for a substance, that is sucrose, and 3 different trials are done, and for each trial student gets a different data. Student A gets 3 set of data and its mean value is 184.7 degrees Celsius. Similarly, the next 2 students has different mean values. Mean represents nothing but average. But the actual value or the accurate value of the sucrose is 185 degrees Celsius. So by looking at these 3 data, you can easily conclude which values are accurate. Student A has represented or recorded 3 different trials containing a mean value which is very closer to 185, which means this value is a true value. or this value is the accurate value. Student B is not that very accurate, and student C is not accurate at all. If you compare individual students' data, we can get more light about whether these data are precise in nature. So trial 1, 2, and 3 represents a closer values to each other. So we can call this student's value as accurate as well as precise. Student B has 3 set of data, and these data are not closer to each other. So we can say that they are not accurate, at the same time they are not also precise in nature. Student C has 3 set of data, and these data are far away from, compared to the student B and A, it is far away from the true value, and they are closer with each other, hence they can be accepted as a precise value but not accurate value.